Let's look to see how we solve this rational equation, an equation that has fractions but it has an equal sign. So we're trying to solve for x. In order to do that, we want to find an LCM, a least common multiple, so that we can clear our fractions. 15 is 3 times 5. So that's our multiples. 5 doesn't break down, 3 doesn't break down. So what they have in common, well, common to all of them is nothing. But some have a 5 in common, and so we can account for that. And then some also have a 3 in common, some of those denominators. So it looks like our LCM should be 15. Now what we're going to do with that 15 is multiply each term in this problem by 15. And you'll notice here we have 3 terms. So you need to know the difference between factors and terms. Now the whole reason why we multiplied by this LCM was to clear out our fractions. So 3 times 5, which is 15, will go into 15 just once. 5 will go into 15 3 times, and 3 will go into 15 5 times. Now we need to write this problem so we can see what we have. Using the distributive property, 5 times x is 5x, and 5 times negative 2 is negative 10. And here's where things get to be a little tricky. It says to subtract, but I need to subtract all of this stuff. So I'm going to use parentheses to make sure I don't make a mistake. 3 times x and also 3 times negative 3 is equal to our 13. Everything else over here had reduced out. Let's write this without parentheses. To clear parentheses, we're going to change this and then distribute that negative sign to both of those. We still have our 5x minus 10, but now we have a negative 3x and a positive 9 is equal to 13. So let's combine like terms. We have our 3x and 5x is 2x since the 3 was negative. Negative 10 and a positive 9 is negative 1 is equal to 13. Now we still have an equal sign, which means we're solving for the variable. We need to get x alone. We need to get rid of the furthest thing first. So we can add 1 to both sides. 2x is equal to 14. Still trying to get x alone. We can multiply both sides by 1/2. So that gives us x equals 7. Now I don't know that this really is the answer because originally our problem had denominators. So this is where restrictions sometimes take a play in giving you the correct answer. If there is a denominator if there's a variable in the denominator, that variable cannot have a value that will cause the denominator to be 0. Since there are no variables in that denominator, x equals 7 is a fine answer.